Thank you for being back with us. Next up, we'll focus on technologies, applications, gaps, and how to bridge them. The panels will focus on how existing Earth-based technologies can be modified or implemented in space, and how space technologies can be modified for use and improve our life on Earth. Our next panel will be focused on space, connectivity, and the Internet of Things. Our civilization's technological connectivity has proven to be a catalyst for innovation, but also difficult to maintain and manage, especially during the COVID-19 pandemic. Global connectivity enables companies to grow and international presence, connects us to our loved ones, and allows astronauts to seamlessly keep in touch with their loved ones also. Running the session is Miss Elodie Viau, Director of Telecommunications and Integrated Applications at the European Space Agency. She is also the head of the European Centre for Space Applications and Telecommunications Centre.
Thanks, Sarah. Welcome everyone to this session. I am joined here with a very knowledgeable panel of people that are with me today to talk about the importance of connectivity and the IoT and advanced technology and how it can serve our everyday life and what will be the opportunities moving forward with this connectivity in our world. So I am joined virtually today because due to COVID with a set of panelists. We are going to start by a roundtable that they can, all of them, introduce each other. Maybe we start with Bülent Altan.
Of course. So thank you, Elodie. I'm Bülent Altan. I'm the CEO of Mynaric, a German company building laser communication terminals for use between space assets as well as in aviation. I've been with the company for 2 years, and previously I was the VP of Avionics, Guidance Navigation Control at SpaceX for Falcon 1, Falcon 9, and Dragon, and also the VP of Mission Assurance for the Starlink program. Thank you.
Thank you very much. And Guido Baraglia is also with us today.
Thank you, Elodie. So my name is Guido Baraglia. I'm the Principal BD Manager for the Satellite Solution Business Unit in Amazon Web Services. I'm actually kind of a veteran in the industry. I started in the 80s with ground station and then worked into a major European satellite operator and then moved into monitoring and control in the last few years. And I've joined AWS 9 months ago.
Thanks for joining us today, Guido. And now I'm turning over to Fabien Jordan.
Hello, everyone. Thank you, Elodie. Thanks for having me on this panel. I'm the CEO and founder of Astrocast. Astrocast is a startup or scale-up, I should say, of about 60 employees based in Switzerland with a presence in the US as well. And I have a background in engineering, and I had the privilege to build the first Swiss satellite back in 2009, and this is how I really started to work in the nanosatellite industry. Astrocast was the first startup to explore and this idea of using nanosatellite for IoT services globally. And today, thanks to our network, you can now connect millions of IoT devices everywhere on Earth and opens many, many opportunities.
Thanks a lot. Very impressive as well. And last but not least, for sure, Raz Itzhaki is with us today. And over to you, Raz.
Thank you. I'm Raz. I'm the CEO of NSLcom, an Israeli startup. We build deployable antennas for nanosatellites. So basically, we enable either a very high throughput or a very sensitive IoT measurement in space for very small satellites. We exist for 5.5 years. Prior to that, I was managing the nanosatellite department at Israel Aerospace Industries. Happy to be here.
Thank you so much. So as I said to you, a great panel today, and it's a very privilege and honor for me to be chairing and moderating this panel as the new telecom director of integrated application of ESA, the European Space Agency. And therefore, without further ado, as we are all virtual today, I'm turning over Bulent, and asking you this first question of how the COVID-19 pandemic has impacted your business decision, activity, and future plan. It's making us to be virtual today, but what is the impact on your business today and opportunities eventually? Right?
Of course, I think, yeah, as you said, we have to split the question into the opportunities and the recognition of what the space industry can do for telecommunications for everyone, but also the impact that we had as a business, like everyone else in the world. It has changed the way we do work. If you start with the impact, I think the impact has been, of course, there has been impact onto our company. We are all working virtually. What we do here today for this conference is the same way we do a lot of our work today. The person-to-person meeting has been exchanged with the virtual meeting for many of the topics. But I think it has gotten us more process-driven. It has gotten us a little bit more organized in terms of writing down everything. So there is definitely positive changes happening in our in the companies as well, and we've been there also. I think we've been able to keep up a good set of regulations within the company to keep the impact low and actually keep our throughput both in engineering and production. On the opposite side of the spectrum, though, I think when it comes to opportunities, it has had a profound effect both to us and our customers. As we see, the COVID pandemic has moved a lot of people to remote working, and in many cases also to reverse migration. Today we're talking about reverse migration from many places, from the large cities back to where life is cheaper and more comfortable, back into a lot of young professionals have moved back with their parents somewhere less densely populated, and therefore the communication infrastructure has been pushed to the brink of what it can do and probably what it cannot do. And that is really given the fact that terrestrial communication infrastructure is non-adaptive. It is wired, it is hardlined, and it cannot rebaseline itself like a wireless communication setup can be. And therefore, we are seeing that that space has to play a bigger role in the fact that it is adaptable. LEO constellations, for example, are very adaptable. It can really make a much better solution in times of crisis like these. And therefore, our customers and we are seeing an increased interest in our business. We've seen that all around, that people are much more receptive to space-based connectivity and therefore also our products.
Thanks a lot, Bulent, for this first answers. And you have highlighted already the importance of connectivity during these COVID phases and post-COVID phases if the people, as you said, revert migration has occurred, right? So what are the benefits does the space industry bring to the ability to provide internet communication infrastructure? So I'm turning now to Raz for this first answer, and then I will follow with Fabien.
So thank you. It's a great question. I think we can discuss the benefits mainly in terms of agility and flexibility. As Bulent says before, what we need is the ability to adapt to new situations. And actually, every day today is a new situation because the reality is changing faster than we can predict it. And when your prediction is infringed, what you need to do is to adapt. We don't have time to put infrastructure fast enough in order to adapt. We need to use existing infrastructure in order to use it better to the new situation. And there's no more adaptive infrastructure than space. You can provide communication to areas where before you could not, or you didn't have to. You can change, if you have a constellation in space, you can focus, you can change the constellation structure, frequencies, and even change the timings that you use certain assets on ground and in space in order to optimize for that. So that's for agility and flexibility. And I think that the need for that will only grow because as we go further, and as we have people working on remote locations and having their assets in different places, I've been managing my company from home for a year almost. The importance of a physical location for the company is becoming again a question. Where is my company located? Is it at my home, at the office, in my head, in my phone? And all that is changing every day.
Thanks a lot, Raz.
Exactly. Thank you. Go ahead.
Thanks a lot. So I think what you have said is key, that to be able to adapt and to be flexible and agile to follow the changes.
Mm-hmm.
So that being said, Fabien, any other points that or any other benefits that you would like to complement that the space industry bring to the ability to provide internet and communication infrastructure?
Well, obviously, I think it's important to remind everyone that the planet is covered by terrestrial networks, but only a small fraction of the planet. Actually, we're talking about 10 to 15%. And if we address this, so this is why we need broadband satellite services like we are all witnessing the impressive development of these networks. But if I answer this question specifically for the Internet of Things, when we talk about IoT networks, we think about usually about terrestrial networks like LPWAN solution like LoRa, Sigfox, or cellular-based IoT. And this is the same problem. You still need to cover 90% of the globe, and space infrastructure allow you to do that. And until now, there was no solution to directly connect IoT devices globally in a cost-effective way. So this is why we created Astrocast, and we have solved this issue using a network of 80 advanced nanosatellites that we're going to launch progressively in low Earth orbit. And we can really cover the entire planet at very low cost. And we can position ourselves as an extension of this terrestrial network, playing with both cellular entities or LPWAN networks like LoRa and Sigfox.
Thanks a lot, Fabien, for this compliment. And Bulent, maybe you want to add a word on this question.
Yeah, I think a lot has been said about the fact that we need a planet covering capability. I think it's the most important to realize that over the last century, when we were starting with the telegraph up until now, we were concentrating our capabilities of connecting people where density was there, and that doesn't hold anymore just serving that. I think Fabien gave a really good example. IoT's importance comes in when, especially when we think about our planet. When you start leaving the cities, when you start leaving the densely populated areas where communication has been solved, and when you get into the oceans, the desert, the forests, the everything, and this can have profound impacts. And this is what the space industry needs to solve today. Distributed temperature sensors here in California that are distributed, that can find a forest fire, can have a profound effect on the life we have on the city right next to it. But those places don't have the connectivity today to have sensors deployed like that. So it is about solving terrestrial problems without the constraints of terrestrial communication. And interestingly, what the space industry needs to be cheaper than is not other launches or anything. We just need to be cheaper than picks and shovels and construction workers, because that's what really is keeping terrestrial communication at bay. And interestingly, we can be a lot with the onset of new space, with the onset of cost-effective access to launch, with the onset of capabilities like laser communication from my company that is targeting cost-effective solutions, commercial solutions today. We can deploy these solutions at a competitive price than laying cables everywhere.
Thanks a lot, Bulent. So you have touched on it about the Internet of Things and the cost competitiveness, like Fabien did. And I would like to ask to Fabien this follow-up question exactly, and how can Internet of Things and advanced technology integrated to the space industry to improve the global communication and everyday life. You have touched with Bülent to a few examples of those everyday life, and could you tell us more about it?
Yes, absolutely. So, first of all, what we have seen during the past 5-10 years is an evolution on the sensor side of things. You know, with the IoT networks, terrestrial IoT networks being deployed, the sensors are now much lower power. They are low cost, and I mean the landscape has evolved a lot, and the large companies are educated about IoT now, and I think it's really the right time for an IoT satellite constellation to establish itself. And what we also witnessed is that this terrestrial network, they suffer from not being able to cover 10, 20, 30% of the assets of their network because of the simply it's not interesting for them to deploy antennas on the ground where the density of assets is not high enough. So for us, the focus with our first commercial service is really applications like tank monitoring, water tank monitoring, propane tank monitoring, and environmental sensors, water quality, measurement of the air quality, ag-tech application, monitoring of the moisture in the soil, also the nutriments in the soil, wildlife tracking, livestock tracking. So there are really plenty of opportunities that need 1, 2, 5 messages per day, and that we can solve with our first commercial service. As we launch more satellites, we will reduce the latency, and this opens up the market significantly with many more applications that become in our reach, applications like personal trackers, satellite trackers, when you go for outdoor activities, if you need to send SOS messages, and all type of similar panic button applications that you can see in cars or different vehicles. So there are really plenty of applications that will need satellite connectivity and are depending on the latency that can be offered. But we think in terms of timing, now is the time of satellite IoT, because everybody knows what IoT is, everybody knows the limits of terrestrial IoT, and really it's now the time to deploy a system that will be competitive, but also that is able to grow in the existing ecosystem of technology. I just wanted to add also that the evolution of the technology on the ground has also deeply impacted the way you design and build satellites. Our satellites are now extremely lightweight and miniaturized. We're talking about 5-kilogram nanosatellites that cost much less than what you would see traditionally in the telecom industry. So all of this is really completely changing the landscape and the business models, and we are coming up with very attractive offers to these many applications that are frustrated because they have to pay a lot of money today for expensive satellite communication, and this will change.
Thanks a lot, Fabien. Thanks a lot for all your explanation and a variety of panel. And we can see that there is an opening for new application and new services coming up. So without further ado, I want to give back the floor to Guido to also see from his perspective with the cloud technology and what do you see the commercial cloud-enabled IoT and advanced technology, especially complementing what Fabien said, going to integrate to the space industry to improve the global communication and our everyday life? That will be my question for you, Guido.
Thank you, Elodie. And I really want to connect to what Fabien just said. And for a satellite operator like he is, establishing a ground IoT infrastructure, designing and deploying devices, connecting them to the internet, gathering and analyzing all the data that those devices collect can be challenging, costly, and definitely is time consuming. And if you think about adding cloud instances to what it is, the ground segment operations for what is operating support system or business support system, the cloud can actually provide a much faster, more flexible smart and sustainable approach on a global scale. And so the economy, it's all there. If you think about speed and security of provisioning batches of new devices into the network, if you think about a much higher level of automation in managing configuration and security of the devices themselves, generating shadow configuration, distributing, upgrade over the air, those are only few of those advantages that the cloud can actually bring into satellite IoT operation, and more in general in the entire set of space-related operation. The ability to scale and innovate with scalability, it's are at the same time simple and reliable, and require much less expertise when you use the cloud as a backdrop onto your operation. And the low cost of entry, the pay-as-you-go service, provide the ability to grow or shrink the operation by a click of a mouse. And that's something that is extremely difficult in a legacy environment. If you think about the AWS ground station service, that's something that provides antenna receive and acquisition capabilities on a pay-as-you-go approach. So you pay only for the minute of antenna that you're actually using.
Thanks a lot, Guido. That's we can see that the cloud is enhancing one step further. So without further ado, I would like to turn back again to Raz and ask, given this context of having now those new IoT and advanced technology, to tell us more about what opportunity open up with the integration of IoT technology with space infrastructure. Which a new opportunity are you looking at and foreseen in the future?
So the basis for this conversation is that the new era of new space have enabled new economics. The reason why there's not millions of ground sensors is simply because connectivity to small devices has always been too expensive to have direct IoT device to satellite communication. Now, if we want a farmer to be able to monitor his fields and spread tens or hundreds of sensors, each sensor needs to cost, let's say, $10, and the cost per month should be few dollars or even less. In order to reach that, we need to integrate whatever we can in order to lower the capex of the constellation and the terrestrial infrastructure. And for the first time in history, this is now possible because of the advancement that we see here in this panel. If we take the cost of megabit per second, basically what you need is to finance the NRE, the launch, the manufacturing of the satellite and operation, and to divide it by the amount of sellable throughput you can provide. So as long as the numbers are efficient and cost effective enough, as we say, we're only bounded by our imagination, because it starts with providing the existing IoT with lower prices. But then again, let's talk about agriculture. Why not having a camera over each plant in order to make the watering of and the pesticide system specific to the plant? It is limitless. For the right cost, you can sell any amount of connectivity, and this is, we're at the verge of a new era here. So the opportunities are really limitless. The question is how soon we can get these systems down to the farmer, and then to analytic system that can sit and analyze the data, and then to create new wisdom and new insights that can actually prove to bring more revenues to the customer and to the analytics system and to the entire ecosystem. So the world is just it's open for IoT. It's up to us to bring it to the end user.
Thanks a lot, Raz. And following up on the question that you have yourself mentioned, how fast can we could give that to the customer and to the farmers that you are mentioning, and to do the analytic of it? Guido, can the cloud help us again, or what opportunity does the cloud add up to that and open up for the integration of IoT technology into the space infrastructure? Does it help for the analytic as well, and moving one step further?
Absolutely, and thank you, Elodie, for the question. I like what Raz just said about the granularity of the sensors, the ability to go into the single individual plant and collect information. When people were actually discussing about 5G a few years ago, was saying about having a retransmitter on every lamppost, and this connects very much with some of the cloud push, and in particular AWS cloud push, to generate edge computing capabilities. So bringing the ability of the cloud closer as possible to the sensors, and so the information can be collected, can be processed, and the big advantage is that the process information takes up a lot less space than the raw data. And so even the communication side becomes far more efficient, and the bandwidth can be used for other things. At the same time, you have the capability to move the decision-making process as close as possible to the sensor. And that is another advantage. The cloud has, and AWS has capabilities into product called Snowball and Snowcone, which are actually extension of the cloud where users can actually store data or process data. We do have a more advanced version, which is called Outpost, without going into much detailing and getting into a commercial speech. But the ability of the cloud is that of generating a lot of analytics for those data. We can actually do a lot of artificial intelligence and machine learning. Think about, even though it's not exactly directed at the IoT world, but think about Earth observation. You have a satellite in the sky that is taking picture of a planet. Doesn't matter if the picture is covered in cloud, that satellite will transmit that image down to the ground. If you have artificial intelligence that is capable of collecting the information, analyzing the picture, analyzing the cloud coverage, and then having the possibility to decide whether or not that image can be transmitted or needs to be transmitted to the ground station, it's a big advantage. And the advantage of the cloud is that we are able to deploy all this edge technology at scale across the globe. And that's the big difference, is that we can provide the same ability to all the user at the same time everywhere in the world. And I mentioned a moment ago ground station. Ground station is a fully managed service, and you can control and command your satellite. You can downlink data, you can uplink data to the satellite, and actually you can process payload in real time whenever that is the case, without having to worry. And that's the key element about huge capital expenditure into having a big ground infrastructure that can be provided through the cloud.
Thanks a lot, Guido. Thanks a lot for your detailed explanation. So you were mentioning 5G, and I have to ask a question, and I'm turning again to Raz, and maybe it's like a question that will make you smile in front of your computer. Will 5G kill satellite communication? And here I think we need to enlighten the audience that 5G can also be used through satellite. And Raz, I'll let you further answer to this question.
So it's a good question. Many people think that different communication methods are competing, and there will be one victorious communication method that will kill the rest. I believe the contrary. I think that the communication systems depend on each other in order to make each one optimized for the things that it is best at, and not to have it deal with the entire infrastructure. Let me give an example. So 5G is wonderful for edge computing, as was just mentioned. But then if I have an area which has wonderful edge computing and a lot of information is being generated there, I need to transfer this information to the backbone, to the center of the network. That's called backhauling. Now, in order to do that, I need either a terrestrial infrastructure or fiber or towers with RF connectivity or satellites. Satellites are the best way of providing backhauling between these flowers of 5G areas. So if we learn how to complement these communication systems, and for example, a nanosatellite of ours, a single nanosatellite, can relay the entire area of 5G because of our enhanced communication capabilities. Thus, these communication systems, of course, you're not trying to use 5G on the air or at sea, right? You may create some nanocell or picocell, but then the backhauling would definitely be done by satellites. And then if we augment it by the capability that Fabienne was talking about to directly sensor to satellite communication, then you have actually a whole area where you can choose what communication system to use. Whether you want to have like a LoRa system, like one center terminal that is talking to the satellite where you spread all your sensors, or in other cases, you'd use direct communication or just perform the backhauling through a satellite. So the more we complement each other, I think the better service and better costs we can provide to the end user.
Thanks a lot, Raz. And you are helping me for the transition to my next question for the cost element. And having discussed the direct to satellite and sensor to satellite IoT communication. So Fabien, what are the opportunity really that our audience can now have an open up with affordable direct to satellite or sensor to satellite IoT communication? Tell us more about the future and what are the opportunities that you see with this affordable and cost efficiency that is coming up?
Yes, this is a good question, and I can only agree with what Raz just said. So, you know, if we keep things simple, there are basically usually two types of architectures, right? You have one that relies on the network on the ground, like a LP1 network, a LoRa network, and you have a gateway. So this is, let's say, a backhauling configuration, and then you have the direct to satellite, or the sensor to satellite communication, and this is what we focus on. This is what we are good at, and there is a huge opportunity here because it's very difficult to do that. We think the opportunity is in the hundreds of millions of devices, and this obviously means first of all the mobility sector. If you have an asset that is mobile, it will at some point leave the local network where it is connected. So you need to be able to switch to a direct satellite communication, and that's what we can do. So when I say mobility, I'm talking about, you know, it goes from trucks down to scooters or even planes that you can track, and you can also solve a lot of issues in the maritime industry. We are discussing with the leader in the fishing buoys manufacturing industry, who have invested in Astrocast and are very interested in what we can achieve to help them connect each of these thousands of buoys globally. We're talking about animal tracking. When you have birds or mammals migrating over large distances, there's only one way to achieve that. It's a direct link to the satellite. And the only way to make it very efficient is having access to the right spectrum. And this is a very important point. As you all know, in this industry, it's all about spectrum. And if you get the good spectrum, then you get the good system. And that's what we achieve. We are one of the only startup who managed to access the very precious L-band, which give us very tiny antennas, very low power consumption, and an entire system that is really optimized and very attractive for our customers. We're currently launching our five first commercial satellites. So they're going to be launched with SpaceX on Thursday. and they are equipped with the L-band capacity. And in parallel, we're deploying our first product, mass producing our first product based on L-band as well. So this gives us a very good advantage if you compare to other frequencies like VHF, UHF, which means large antenna, larger satellites, etc. So very happy about the solution we've found together with our partners, and we really are excited to deploy this commercial network.
Thanks a lot, Fabien, and we wish you all the best for your upcoming launch, for sure. As the Telecommunication and Integrated Application Director of the European Space Agency, the next question is that it has been a pleasure for me to be with you, all the key industry leaders. And I want to hear from you, and I will ask first Bulent and open the floor to the other panelists. I really would like to understand, and I'm asking you like very deeply and very candidly, what role should government and agency play in supporting the rollout of space-based connectivity? What are you expecting from agency like the European Space Agency and other? How can we best support your industry? Please, Bulent, I'm turning over to you.
Thank you, Olivia. I think that's a really good question. I think overall, the role of the government and the role of the agencies in the space sector has been going through an evolution lately. I think we all now use the term new space in a certain way, but I'm not the biggest fan of that, to a certain extent, of that wording, because it really doesn't give anything new. The physics of space hasn't changed. The way to survive in space hasn't changed. What has changed is the way we think about space and how we utilize that. We talked about constraints, we talked about cost and everything. What has changed with new space is we're trying to take the constraint away of what a space mission ought to be. The number one constraint that space missions or space assets would give to any end user was cost. It used to be that cost was the number one driver. If you used any time space assets, that's something that only governments and agencies could use, because for everyone else, like we use the word farmer and fisher today, it was out of the reach of those people. In the meantime, that has changed. With the new space wave, or the wave that is now named new space, people are thinking in commercial terms. They want to deploy services exactly for everyone in the world. And therefore, the role of the government and agency is changing from a sole purchaser or sole user of space assets to that of an enabler. Which for me means that the role of the government and agency is not to dictate what the final solution ought to be, but to be an anchor customer of it, and then leave the innovation as much as possible to the commercial entities. I think we've seen multiple large programs of the past where, of course, it made sense for the government to completely dictate what the final solution will be down to the lowest detail, because they were the only customer of it, and they needed to really ensure mission assurance, because there was also a sole provider of that. I think what governments now need to pivot to is be the anchor customer, be the early customer of commercial companies providing commercial services that are going to, at the end, give solutions to everyone. Try to get away from the driver's seat, dictating everything that needs to be done, but take the solution as is, realizing that there are more constraints than the governments and the agencies' constraints. So I think by being an early customer, it can give stability, like through the COVID times, to all the different new space companies involved. It can give a guaranteed revenue for the future, which in turn will probably also bring private money towards all these companies that are trying to make space happen in certain ways that we couldn't even fathom in the past, like in a very innovative way, in a cost-efficient way.
Thanks, Bulent. So point well taken, and fully on board with you to be an enabler. Anyone else in the panel want to react, and maybe raise your hand for the first one who wants to react? I see Raz, you have removed your mic. So Raz.
Yes. So
I come to Guido next.
I think that Bulent question actually took away most of my points, because he said it all. So I can only reiterate and emphasize the good things you've said. First of all, I think governments are the perfect early adopter. When a VC comes to invest in a company, they need to perform a due diligence which is partially technological, partially financial, HR, etc. Now, for the space industry, which is a deep tech industry, due diligence is difficult because you need people that are experienced in that area in order to provide comfort for the investors. So there's no better due diligence than a government customer, because the knowledge and the capability to assess risk and to take it exist in governments like in no other place. Now, after the government takes this role of early adopter and assessor of the company, there is a dance between the government and commercial investors or clients. Because if the company becomes too government prone, then it has limitations on its ability to share information and to be transparent to investors, which can overcome the benefits. So it's a dynamic situation. And actually, in Israel, there is a wonderful process where the government actively approaches VCs and says, we have chosen to invest in a certain company. We are providing the technological due diligence. Come and invest with us. And it's a wonderful and very successful initiative. And I think it encompasses the benefits. Now, as we say in many cases, government, it's not a bug, it's a feature. You need to know how to live with it. And if you adapt well, it becomes a wonderful partnership.
Thanks a lot, Raz. I think I like your word partnerships. That's really what it needs to become, a private-public partnership.
Yes.
With the equilibrium and balance. I think that's your message here. So thank you so much. And Guido, you want to add a few words from your point of view, being more like also linked towards our famous cloud as elements of the story in this panel. So is there any things that you want to say to the governmental and space agency on how you see the partnership or enabler or role, or like Bulent and Raz has already mentioned?
I just want to mention that actually AWS and the European Space Agency have already partnered into the business incubation centers that the European Space Agency has all around the territories. And so AWS provides technological and financial support and expertise to those startups that are actually part of the BICS program. And to me, that's already the example that this kind of partnership, public and private, is working and could actually be very beneficial for the aerospace industry.
Thanks a lot, Guido. Fabien, last word, and before I'm getting to closure to this fascinating session that I should admit I'm, again, very pleased and very honored to share with all of you that are leaders of our space industry. Fabien, you want to?
Thank you. Well, I don't have much to add to what has been said about the government, except that we are very happy to have a strong support from the European Space Agency, a strong support from the Swiss government, and believe it or not, our first customer is actually a government. They signed a purchase order even before we deployed our commercial satellite, which shows also the role they can play, and this has been very nice for us to witness.
Thanks a lot. Thanks a lot to all of you again once more, and to all of you that have been listening to this video. I hope you enjoy it, that you have learned as much as me, and that you are still very fascinated and stay curious in the space industry. A lot of opportunities to come with the Internet of Things. Thanks everyone. Thanks to all my panelists that have shared with me all their interesting thought and vision. So I back over to you, Sarah.
Thank you, Ms. Vio. And as we heard, there is no doubt that we are all waiting for the 5G and satellite communications that will play a major role in this reality. Our next panel focuses on space and remote sensing. The commercial market is growing at an impressive rate as new businesses opportunities emerge. Satellite constellations are replacing single monolithic satellites, and advances in materials, miniaturization, and image processing are enabling new business models. This panel will discuss new developments and technologies with this field, led by Ms. Imbal Kreis, Head of Innovation System Missiles and Space Division at Israel Aerospace Industries.
Thank you, Sarah, for your lovely introduction. And welcome all to the Space and Remote Sensing panel. The remote sensing commercial market is growing at an impressive rate as new business opportunities emerge. Satellite constellations are replacing single monolithic satellites, and advances in materials, miniaturization, and mostly significant image processing are enabling advanced business models. This panel will focus on the challenges in the Earth observation market. What are the future trends? What are the expected increasing opportunities? We should set broader expectations from the remote sensing capabilities in order to apply to more application domains: civil, commercial, finance, insurance, investments, in order to use the remote sensing products as business indicators for leaders and for decision makers, especially how to direct new applications to do good to the global community and to maximize the impact on our day-by-day life here on Earth. So let's start to share and discuss various perspectives. Our panel includes high level of panelists from the industry, integrators, governments, and commercial sectors. Mr. Massimiliano Vitale from Planet. He is the VP Business Imaging Operations for Planet globally. Welcome, Massimiliano. Mr. Guy Eschel from Elbit Systems in Israel. He is the Space Remote Sensing Unit Manager. Mr. Eli Peretz, the CEO of Utilis. You will tell us later on what is so special in Utilis. Mrs. Tali Markovich from Intel Geospatial. She's the head of software COE EGI unit. And the last is Mr. John Hoffman from DLR, Copernicus Program Manager from DLR Space Administration. And I would like to address the first question to Mr. Massimiliano Vitale regarding dealing with the future trends and what will be the future growing markets for Earth observation products. Please.
Thank you so much, Imbal. It's a real pleasure to be at this panel today. I will take a chance to show like a couple of UGRAs while I am presenting. So I'm going to try and share screen now. So basically, what I would like to do is to give you a quick introduction of what Planet is. So Planet was founded about 10 years ago with really one mission in mind: to image the entire Earth every single day and make global change visible, accessible, and actionable. Since then, I believe we accomplished a lot. We have built and launched more than 400 satellites. We launched with virtually every rocket that's available on the commercial market. We grew from the proverbial garage in Silicon Valley to a company that has more than 400 employees worldwide. We expanded our operations in Europe to more than 100 people. This is the area of the business that I manage for Planet. And from our offices in San Francisco and Berlin, and today from our kitchens and living rooms, we operate the largest constellation of Earth observation satellites in human history. Our satellites, which you can see on the screen here, image every point of the Earth every single day at 3 to 4 meter resolution. But not only that, we also have high resolution satellites that we call SkySats that can zoom in and take a look at specific locations multiple times a day, up to 10 times a day at 50 centimeters resolution. Combining this together, you have an unprecedented capability that allows our institutional and commercial customers to monitor the health of tropical forests, to efficiently manage their farms and crops, monitor activities along the borders, and in a nutshell, to take the pulse of the planet. But our mission isn't finished yet. As we work to improve the quality and the richness of the data sets, we also work towards that make the change actionable part of our mission statement. And what I see, every day when I talk to many industries is that all those customers, these decision makers, they need to make informed, timely decisions. So they don't need just more pixels. What they really need is accurate and concise information. So what we call the actionable insights. So coming straight to your question, Embal, where do we see the Earth observation growing? Well, I think that the success of Earth observation as an industry is really linked to our capability to make the leap from pixels to insights. And this is really why I'm so happy to be together with you all at this planet. If we look at the future trends, what's gonna make this business grow? I think that first and foremost, we have agriculture. Today, it's already our largest vertical, and I believe it will continue to grow as we get more and more applications and workflows powered by this type of data. Simultaneously, we have government use cases and defense and intelligence that continue to be an important vertical. But what I believe is going to be really the next big thing, if I can say so, is really ESG. The world today is facing major environmental crisis. Social and corporate responsibilities are a daily topic in all boards. And as countries and the European Union in particular starts to implement green policies, in Europe we call this the European Green Deal, I think other countries will follow, and sustainability will become a big driver for the near-term future. I think Earth observation really has this potential to be an enabling technology to empower policy monitoring, but also to help businesses understand their operations, make them more efficient from an economic and environmental perspective, and finally embrace their ESG goals. So I believe, we at Planet are uniquely positioned to be an important actor. And I think there is space for a number of us around the table to grow their business in this direction. Thank you.
Thank you very much. I addressed this same question to John Hoffman from DLR to see the governmental and the space agency perspective on this issue. Please, John.
Thank you, Embal, and I'm extremely happy to be here on this panel with you. And it's an honor to be here. DLR is one of the biggest engineering institutions in Europe, and it's also the National Space Agency for Germany. And of course, as this, we implement our own national programs, including an ambitious Earth observation program, but we also steer and influence the European programs implemented via the European Space Agency and increasingly also the European Union through the European Commission are playing a role. And of course, with this, we have a very strong applications activity also to help develop new applications and start supporting companies, in particular in Germany, of course, to succeed in the growing markets that Massimiliano also referred to briefly, and that you and Embal mentioned some of them in your introduction. So to come to your question, the future trends, I think one of the things, the top topics really that have been keeping us busy is both, of course, what we call new space, more strongly commercially driven development, looking at business models more than scientific results, and that has also, of course, built on the private investment and the types of compromises that the private enterprise have taken that maybe institutional missions wouldn't have taken because their objectives have been different. So the two developments that we're seeing, rapid technological development at the sensor level or satellite level, including the new systems, the development of the business models, obviously, but also the development of the use cases. And that is very much linked to the increase in offer through both a very ambitious institutional program that still exists with Copernicus, for example, at the European level, but also the commercial players, large constellations. Massimiliano showed the impressive assets that they have already. And of course, there are others. So it's a very rapidly growing market. And then there's the use of these data through artificial intelligence and big data applications that make new services and new applications possible because these things come together. And that, of course, is starting, and that's something that concerns us very much, reshuffling the whole ecosystem, because suddenly there are new players. I mean, the institutional Earth observation domain was a fairly closed club for many years, and this has really changed dramatically over the past 10 years or so. And that's a development that is continuing and even accelerating in some cases. So I think what we will see is a very strong growth in specific market sectors that are already fairly mature or maturing: agriculture, environmental compliance issues, the Green Deal was just mentioned, so these more institutional ones, but also the more mundane sectors, I would say, that are not traditionally Earth observation driven. Finance, insurance, these are where Earth observation input will be part of the solution, will be maybe even a small part in some cases, but will nevertheless be an important one. And maybe even those new stakeholders and users won't, in all cases, know that they're using Earth observation data, but this will help driving the development, and it will make it more viable commercially. So that will be a very interesting one. And of course, integrating the Earth observation data with different types of data, not from different satellites, but think of in situ data, of course, other types of observational data, but think of sensor data from cars integrated with Earth observation data. Think of social media input that will then drive or inform total new sectors that we haven't even thought of yet. And that, I think, is something that's within reach, say 5 to 10 years, definitely.
So maybe we are in an evolution process to this new market sectors, or a revolution. Let's see, because we are talking about a new space era many years, and still the new space era definition depend who you ask and when. We don't know exactly how to define well what is the new space industry and what are the new space activities.
I think it's an evolution more than a revolution. I do think there will be a place for large institutional missions for many years to come, because they today are forming a backbone of this whole ecosystem. They're complemented more and more with the commercial systems, but I don't think that they will be replaced anytime in the near future.
Thank you. Thank you. And I'm moving to Tali, to Intel Geospatial, to ask this future trends issue. Please, Tali.
So thank you, Anbar. I would like to start with a short clip presenting Intel Geospatial platform.
Intel Geospatial is a cloud platform that's revolutionizing the way you acquire, manage, and extract insights from geospatial data. From oil and gas and utilities to smart cities, aggregate data from multiple sources, process it, and bring it to life inside 3D environments, where you can run analytics and produce insights that transform your business. Let's look at the platform in 4 easy steps. First, leverage geovisual data available on the platform, including pre-processed libraries sourced from satellites, aircraft, drones, and terrestrial sensors. The existing data is stored in our geovisual data lake ready for visualization and analytics. Combine your own imported enterprise data with the pre-processed platform data. This brings the platform data and your data together to ensure the right context for the required business insights. The data is now indexed, cataloged, and prepared for visualization and analytics. Second, visualize your data layers inside the Geospatial Explorer, a single immersive 3D environment, where you can start to understand and analyze the state of your assets in their surrounding environment. Third, after choosing the analytics application you need from Intel Geospatial, our ISV partners, or your own development team, the Intel AI Workflow Orchestrator goes to work, preparing your data and running the analysis with your chosen application. The AI Workflow Orchestrator supports a variety of analytics, including artificial intelligence and deep learning, 3D reconstruction, as well as computer vision. You get the results you need. Finally, with robust insights, you can review and collaborate in the Geospatial Explorer with subject matter experts. The results of the analysis can be used in your enterprise systems for streamlined operations and optimized business decisions. The Intel Geospatial platform will change how you work with solutions for asset records correlation, vegetation management, fire risk assessment, and visual inspection. Change the way you see the world with an end-to-end geospatial platform built for the future, empowering data management, 3D visualization, and AI-powered insights. Request your demo now.
Thank you, Tali. I request your demo now. Yes, at the end of your clip, I am requesting your demo now.
With a great pleasure. We will organize it for you. But in the meanwhile, I'd like to address your original question. And I would like to address two vectors. One of them is private sector, and another one is the fusion of data from different sources. Mm-hmm. So let's start with the private sector. You asked me, Inbal, during one of our calls, what changed now? Why now it will be different than 10 years ago? And I think that the answer here is in several things that reached maturity. The recent advances in the remote sensing visual data acquisition, combined with constantly growing computer power and new algorithmic approaches, unlock limitless possibilities. New erupting infrastructures like Intel Geospatial enable easy access for the end users, effective management of big and recurrently updated data, and all this is completed by AI-based analysis for actionable intelligent extraction. So let's consider a few examples. I'd like to start with utilities companies. Those companies have assets spread over vast areas. Recurrent inspection is mandatory to monitor equipment status, growing vegetation, and other environmental changes. Another example is municipalities. Municipalities and smart cities, they're very much interested in understanding of what's going on with their roads, traffic sign status, and pedestrian concentrations in order to take decisions. Last example is in this area is oil companies. Oil companies invest a lot in the inspection of their wells for oil leaks in order to avoid, catastrophic incidents and for environmental reasons. The combination between different data sources can also be very beneficial. Some examples for this one. We can use satellite data to visualize and analyze big rural areas. We can identify smaller areas of interest, for example, areas with vegetation and the electrical poles concentration. And then we can send drones to that area of interest for high resolution data collection. And this data can be analyzed and we can detect specific poles that have vegetation too close or damaged components. Another example can be using satellite data for representing context of a city, for seeing streets, for seeing buildings. And then we can have cars having images everywhere they drive, and extract metadata that can also be uploaded to the system and combined with a more comprehensive satellite data. And in this way, we can see close to real time all kinds of changes, like traffic signs removal, like new potholes. Additional opportunities here can be in tighter integration between platforms like Intel Geospatial and data providers to accelerate time to insight and deliver greater value to the end user. Thank you.
Thank you very much. And from you, I will go on to Eli Peretz, the CEO of Utilis, regarding your, you mentioned the utilities companies. Utilis is dealing with also the utilities companies. So Eli, the floor is yours.
Thank you, Inbal. It's a great honor to be here. It is such a great panel. And I'll start with a short clip and then follow up with a few slides. So,
water, a resource too precious to waste, the essence of life on Earth. We can see what it does above ground. But what about below the surface? Just under the surface, under our roads and rails, under infrastructure near foundations, moisture in the soil is creating potential disasters that no one can see coming until now. From a radar satellite orbiting the Earth, only Utilis has the technology to detect the moisture hidden in the soil. Only Utilis can see past the ground and even pavement to map saturated soil under your city, state, and country. We can build that map for you and for the world, and give policymakers, infrastructure managers, and engineers the actionable intelligence they need to make decisions using accurate images and data. Utilis can show you the location of moisture that's putting your transportation infrastructure at risk. We can see what's in the moisture, so you know if you're losing precious drinking water through compromised pipes, and you can move quickly to preserve it. Or if it's leaking wastewater, so you can keep pollution out of the environment. Utilis' technology shows you the world in a way no one else does and gives you information that no one else can. Information people are already using to prevent disasters, maintain infrastructure, set priorities, and preserve resources, saving money and lives. Come see the world the way we do. The possibilities for impact are endless if you have the right intelligence. Utilis, the intelligence to act.
Very impressive, Eli.
okay, did the movie go through well?
Very well, very impressive. Utilis company is a very small Israeli company with new service and very impressive activities.
Just a quick one. I don't know if you noticed, but we are using SAR data rather than visual data. So we are an excellent example of what few of the previous speakers spoke about earlier in regards of taking a use case or a vertical and make a real market out of it. So it's all started with a research that took place a few years ago, and our founder was part of that research of looking for water on Mars. So specifically what Utilis is doing, we are looking for water in the ground, and we are helping water utilities and infrastructure owners to move, and Tali made it very clear, to move from looking for the phenomena blindly into being much more specific on what, where the whereabout of the phenomena. So what Utilis is really good at is taking soil moisture information from SAR, L-band, satellite, and translate it into actionable data that we sell to water utilities and transportation infrastructure to help them to prevent disastrous events and maintain their systems over time. Why SAR? SAR is unique. SAR stands for synthetic aperture radar. It's basically a signal that is active, and it can be a signal or data that can be added as a complement to visual data or any other data. It works in all weather. It works in all weathers. It's day and night, 24/7. It's sensitive to the electric properties. And L-band specifically can penetrate the ground up to a certain level. That helps us to understand what is happening in the subsurface. We are using, right now, there are 2 satellites that can be used for our purpose. We can also use radar that is mounted on an airplane. And I think that what makes the best point is the point that of what we are doing is explaining how we are taking satellite data and make it actionable. I'll skip that one. It's going to take us some time. We are definitely in the impact ground. Specifically, we help with clean water and sanitation. We help with roads and highways, which is a kind of an industry, an infrastructure industry, and climate action. Some examples: leak detection in both treated water systems and sewage water systems is a problem that water utilities are facing as the infrastructure is failing, as the pipe systems are aging, and we are helping them to better maintain and focus their efforts on the right places. Over the years, we have saved tons amount of water for water utilities all over the world. We are talking about a phenomenon that is measured at something like $45 billion of water only in treated water loss all around the Western world. When it comes to infrastructure, we are helping infrastructure owners to better maintain and help them to monitor a phenomenon that is called landslides. This is where the moisture is getting the ground to move in and away from the infrastructure. You can see here another example where, unfortunately, in China, a little village was wiped off because of a landslide, and that was something that could be monitored with SAR images. And maybe the last point I want to make before I address your question, Inbal, is that at the end, the story is to take this data and make it actionable. How do you make it actionable? It's by using tools, standard tools, software tools, applications, and KPIs that helps our customers to understand how to act with our product. Am I still sharing? So just to go back to your question, Inbal, I think that the interesting question is not only where the remote sensing market is going in terms of what we know, it's also about what we don't know. What is it that we don't know that the remote sensing market can address? And Utilis is a perfect example of 2 verticals that our customers don't even knew that we can address it with remote sensing or with satellite data. The key in the future, for the future, would be by having people like us going to different verticals and different markets and explain to them that we have data that can help them.
Thank you, Eli. Thank you very much. And from here, I'm addressing Guy Eshel from the industry, from the leading Israeli industry that produce the high-end payloads for Earth observation satellites, the Israeli observation satellites, that we are working in a very close cooperation. I'm from the Missile System and Space Division. Guy, the floor is yours.
Thank you, Inbal. Let me start by saying that Thank you for inviting me for this panel, and also congratulate my colleagues here. So let me start by briefing what we do in Elbit. As you mentioned, we're in the business of EO, space observation, payloads for the past 30 years. With the first launch about 25 years ago, we were part of large-scale programs and developed and manufactured those payloads. We were also involved in some commercial programs, also large-scale ones such as AROS-A, AROS-B, and recently AROS-C. I think that the most notably our recent launch was in last July when OFSAT 16 was launched carrying our payload, which was a huge success, and we were very happy about that. Along the years, we were also involved in some interesting research program, and recently, actually, we're involved in developing a deep space UV telescope together with DLR, which are also members of this panel. So we're very excited about this program that should be launched in about three years' time, and would support very interesting science. So that's what we have done in the past. And looking at the future, as mentioned here in the panel, we have identified the very growing commercial market, and we're heading towards penetrating this market with more affordable platforms to be integrated in a larger constellations, not as you mentioned in the beginning, monolithic, single event, huge programs, other than that, supporting those constellations. I think that in your question, you asked what would be the future. Well, I don't know. If I knew what the future is, I wouldn't be sitting here. But I do have, we believe that the future in a nutshell is more as far as space observation, more performance, meaning better resolution, more temporal resolution, meaning better revisit times, better spectral coverage. I think that when we mentioned EO payloads, most of us think about the visible band, but there is a lot of information to be also gathered in different and other frequency bands that could be very interesting. And following to what Ellie just mentioned a few minutes ago, is that we also believe that the availability of information and data would be a driver for a market demand. I don't necessarily know what would be the demand, but we believe that with the availability of that information, some opportunities might arise. Some of them we're not even aware of. But there is definitely a growing perspective in collecting information, not only in the visible band, but also some other interesting bands as well. It was also mentioned about, that's referring to the space segment, the sensors, where it's going. I think that the concept that was well demonstrated, the business concept that was demonstrated by Planet, definitely has shaken the market. And once the concept of space persistence was well demonstrated, now there is a ever-growing requirement for again, more performance. So now we see customers expecting not only having a very good revisit times, but they want better performance. And I think that leads to the major question: what is valuable data? What is valuable information? What can I do with this information? Is it good enough for agriculture? Is it good enough for infrastructure? Maybe it's not necessarily the same answer. So we see a trend in the getting a better performance out of the space segment. Definitely that would also influence the ground segment, the processing capabilities. Definitely this huge information that being generated every minute, every second needs to be processed somehow. Old ways of processing would not work. It cannot be done manually. AI, machine learning must take over and transform the data into information. We are also involved in those aspects in some of our programs, and we see that generating data is one thing, but customers cannot even digest so much information, and they need even to transform, not only stop at information, but even evolve to knowledge. So if you could provide knowledge to the customer, that is actually the end game and the ultimate goal of this space segment. So we see trends in the space segment and also in the ground segment that would create. My colleagues has just briefed about different requirements, but we believe there would be more requirements both in the government sector and also in the commercial sector, and that's where we're heading right now.
Thank you, Guy, very much, and that leads us directly to our second questions regarding the performance versus the price and the trade-off between them two. And this question I address to you, Massimiliano Vitale, to tell us about what will be the future optimal working point, if any, especially for the remote sensing constellations.
Yeah, I think I want to echo like Guy's words. If I had a crystal ball, I'll be in a different business. But I think like I'd like to answer your question from maybe a slightly different angle. When I talk to customers, I don't necessarily like to talk about price. I think the conversation is actually all about value. Like this is what's really interesting. So I don't know what the optimal point is. I think Jörn mentioned that in his introduction. I think we're going to continue to see the need for different type of tools to address different needs. So I think like there will be use cases where the exquisite instrument that has the most possible highest resolution, whether it's spatial or spectral or whatnot, will continue to have a role to play. Government-funded mission will continue to have a role to play where maybe you really need to, reach a technological breakthrough, whether it's on Earth or on Mars, I don't know. But at the same time, we see what Luis was referring to, this continuous demand for more persistent information streams. So I think what we are good at and what we learned over the year is to architect systems that are by nature disaggregated. So where we can take advantage of smaller, more compact and efficient systems to build like highly persistent and efficient solutions. And so I think like it's really like a matter of value again. So there is going to be different vectors and there is going to be different points on that quadrant that would be optimal solution. So I'm curious to hear what some of our colleagues here think about the same question.
Yes, I think that Eli from Utilis, from the integrators representative, can see it maybe in another look angle. Please, Eli.
So first, we are in a unique position. We are using SAR data, which has less availability than visual data. And specifically, we're even using a band which is not very popular. So from our perspective, when we are talking about price versus performance, price is not an issue at all. And when it comes to performance, what we need is reliability and access to data before we even go into other questions. So that's where we are right now. We are in an early stage where there are very few sources of data, and all of them are government agencies handled by government agencies. So from Utilis' perspective, what we need, and I wish there was a planet for SAR, think about it, Massimiliano, you have a customer if you ever think of that. What we need is first a commercialized approach by the agencies toward the market. Let's start with that. Let's start with let's make what is available really available and not being kept by the government agencies in a way that only if you answer certain requirements, then you have access. So that makes companies like Utilis, which, with all the respect, if we're looking on the 5 panelists here, there are 2. It is Tali and myself that actually represent the application level, the level that actually goes to end customers and try to connect the data into a problem and a way to solve it.
And the gap is really the resources of the availability of the data.
The reliability. The reliability
and not the amount of the data or the availability of the data.
So I can give up on availability. I can give up on availability if I will get what the suppliers are telling us that they can give us. So there is a gap even between what they say they can give to what we actually get at the end. And that's even before we get into quality and performance and resolution and all the nice things that Massimiliano was talking about earlier. We're talking about much earlier stage in the evolution. So just to wrap up, the key for the future, in my view, is to democratize the data, not from the sense of making it free. We don't need free data. I'm ready to pay. I'm ready to pay whatever it takes because the value is huge. Democratize the data, but by making it available and think of the users from commercialized perspective rather than a government or public thinking.
Thank you, Eli. John, do you want to recommend on that regarding the availability of the data or the governmental sector regarding the commercial one? Or maybe the process, movement or evolution from delivering remote sensing images to service world, to deliver the service, the overall service as a package.
Well, I can try to answer to that a little bit, but I think on the upside, I really want to stress that there has been a very visible open data movement in the government-funded Earth observation programs over the past years. Starting with the Landsat program, probably the most visible one, but also Copernicus from the start has had an open data. And as you might know, Ellie, we have just decided on building an L-band SAR system to complement the existing Sentinels, and those data will be freely available with exactly the argument that you've been putting forward, that the value is in the use of the data. And since they have been funded, in this case, by European taxpayers, the benefit of them is only really realized. Of course, European governments, we hope that European companies will take a substantial piece of the cake, but nevertheless, competition is an important element in the market. So we're not shy of trying that. And I think that's an evolution that will continue. The other element of what you're saying, though, is you've emphasized it's not all about price, it's about availability. And of course, that also has a technical facet, as Tali has emphasized. So the evolution is also including making the data more easily available. Much of that has to do with platforms because of the bulk of the data. Being able to use it on cloud-based platforms, to developing more standardized interfaces. Interfacing with commercially available software, and of course that is also something that that the market has to provide. That's not developed by governments. And then in the end, I think coming back to your question about price and performance, I do agree with what was said. That of course there will be more. I think Gui said that in his answer to the last question. But the price bit, I do actually see that many of the sectors will remain very price sensitive, especially when the remote sensing part is only part of the answer and not the determining one. I mean, many things work already. So, you have to convince that it's also about added value in relation to added price. And here maybe commercial offers like the one from Planet has lessons to learn, making that price a little more sector dependent, because for some the same piece of data will have a different value and maybe also command a different price, and that may help to develop that a little more quickly.
Okay, so it's take us to the next questions regarding the big data science world. From my position as the head of innovation, dealing a lot with the big data world, I am sure that it will have a central role in the future of all these remote sensing sectors to address all types of machine learning and deep learning applications, and to take this data to be more easy to use and more interfaces to all the customers and to all types of markets. But again, the question regarding this is how do you see it integrating between the traditional industries of the remote sensing and the big data world, which is absolutely different because it's an open world, open sources, everything is open, and it is here also between an aerospace and defense industry and the private sector, the startups that dealing with AI, artificial intelligence, and big data, and the data open sources. We are still in a transition phase in this industry and technology. And maybe, Tali, you want to comment on some example regarding using the data and the data fusion of many sources to enlarge these markets.
Yes, of course. Thank you, Inbal. Intel Geospatial is actually one of its main goals is to be this marketplace, this junction, a point of interaction between different data providers to make it easy for them to upload the data there, to provide management and visualization of that data on one hand, and on the other hand, to enable easy integration with all kinds of algorithms. So we see big data science, we see algorithmical advances combined with constantly growing computing power as a key. Some of those algorithms we are providing, but maybe something that is even more important that we are providing is actually open platform with easy ability to integrate all kinds of algorithms. And eventually, I think that we all agree, and the rest of the panelists also mentioned it several times, that for the end user, it is more interesting and probably also more intuitive to use and to consume those actionable insights, like, hey, this area has to be inspected more closely, or hey, this road is too crowded, or this electrical pole requires immediate maintenance, or here we detected a leak of oil and you need to perform maintenance. This is, I think that there will be much more end users connecting to this kind of examples than to actually raw data that they may be sometimes not even aware of what they can do with it. Some additional examples that may be even kind of surprising are coming from, for example, insurance companies. So for me, it was a shock that they give insurance prices based on declarations of the customer. So obviously, the range of mistakes can be huge. And it can be very interesting to learn, to analyze data coming from urban areas and to have assets estimation based of analytics running on this visual data and giving all kinds of insights. For example, a pallet detection and measuring the distance between those pallets and the buildings. Another example can be construction sites that sometimes it can be very interesting to analyze the vehicles and other equipment on those sites, and to provide insights to the construction owners, and help them to monitor and to track the vehicles and the other inventory. So yeah, I think that big data science, algorithms, the ability to extract actionable insights is the key to reach private sector and to reach much more applications.
Thank you, Tali. Guy, do you want to comment on this also? Or the many data sources?
I'd like to, with your permission, to refer to previous discussion points regarding, you mentioned price versus performance. Well, I believe there is more than a single sweet spot. I believe that in the market there are several value requirements. So there are more than one sweet spot. We envision, if we're talking about large-scale constellations of Earth observation ones, like a mixed constellation with very different type of sensors. Let's say you're interested in a area and you have detected something, but you want to investigate that to get to the level of identification. Therefore, you will have different sensor with different capabilities in your constellation. So, well, it's not a single. There is not a precise answer to that. There is more than one solution in the market. I would like also to refer to what Eli just said, and I think that well, at least he should be quite optimistic, since if there is a demand, there would be a supply in the market. So I'm happy to hear there is currently the demand is bigger than the supply. It's a good news for the manufacturers of the physical segments, and I think that we need to make sure that the data is accessible by the downstream companies that Eli represent, and make that data accessible and reliable, so he can transform that data to information and knowledge. Regarding the sensor fusion, well, there is also a challenge in the space segment as far as bandwidth. As the payloads become more complex, more capable, there is a bottleneck of bandwidth, and that would push also for onboard processing in the space segment. So only interesting information, valuable one, would be transmitted down to Earth, and then could be transformed to value to customers, because there could be huge amount of unvaluable information. So that would also push one vector as far as of the space segment. And regarding another example of sensor fusion, there is a different level of sensor fusions, as Tali mentioned. There is the level that take different type of sensors, but also in the data level, as far as of space segment, you might want to synthesize two sources of signals, like, for instance, of hyperspectral punch sharpening. So again, to cope with the challenge of the bandwidth. So there would be one level of sensor fusion in the space segment itself, and another level in the ground segment in the downstream processing. That's what we're looking at.
Thank you, Guy. Thank you very much.
If I may, just a little point here that I think can be beneficial. There is tons of huge amount of data that the end user, the customers, already hold, and it has nothing to do with Earth observation or remote sensing. The remote sensing can take this data and add it as a layer of data and make huge value of it. For example, when we are talking on water utilities or utilities in general, age of the infrastructure or the material of the infrastructure or even the soil itself has a major impact on the sustainability of the infrastructure. Now, taking this existing data that our customers already have and add to that the remote sensing data provide exponential value.
This is exactly lead us to the last questions regarding how to enlarge the Earth observation services globally impact to do good to our life here on Earth. And the example that you gave us just now, Eli, is right there. And in order to do it more and more and to more sectors and to more decision makers and to more leaders. Massimiliano, do you have anything to add on this vector?
Sure. Yeah, certainly. Perhaps before I jump there, I want to say two things. Like, it sounds like we could have like an entire new panel talking about sensors and how we go about doing some of these things. That's great. I really like your point about separating different sensor requirements. This is really something that we have at the core of our architectures. If you look at, we have with the Planiscope, we have the 3 meters high cadence resolution systems. We can spot change globally every day, and then we can task our own high resolution assets to see what's going on, right? That's basically the point that you were making. And business models is the other area, because maybe like 10 years ago, we were selling images by pixels or single files at the time. Like, that model is gone, right? So the way we're approaching this is creating subscriptions that company can build easily a business on top of. Now, going to your question on how can we have a real impact, I think I go back to my point about sustainability. I think, like, as a society, we have a huge challenge, a huge set of challenges ahead of us, and Earth observation can be a critical tool to understand what's going on our planet. You may have read, like, we recently signed a really large deal with the Norwegian government where Planet is providing universal access to imagery collected over all of the rainforest of the world to help efforts to prevent deforestation. Now, this is, again, a perfect example of how you can leverage a technology to address like a really important challenge of society in a commercial setup. And going forward, I think we will see that more and more companies and institutions will put a strong emphasis on revisiting their business practices and make it more sustainable for the future. And Earth observation is a tool that can help both sides of the equation. It can help the government to understand whether policies are properly implemented, and can help understanding the businesses whether they need to optimize and tune their processes to be even more effective.
Thank you, Massimiliano. And your example lead me to another example, which is a cooperation between the Israeli Space Agency, the French Space Agency, and the Israeli Space Industry, and also Elbit System with the Venus satellite, which is a scientific and technological satellite that are performing a scientific mission to perform images to scientific committee regarding environmental conditions and agricultures and topics like that. And it is above expectations, the amount of scientists in Europe and all over that using the Venus satellite images to promote their technology and to promote their science. So it is a real example that saying the same direction that you are pointing on that. So if you have any additional comments, or I can forward to the summing up of our panel. Okay, John, do you have, it's okay? So I'm proud to sum up this panel, and maybe the best way to sum it up is with an additional set of questions. because during this discussion, we added some new questions to our next panel. So there are many questions that I wrote during this panel. Are we now in a transition phase? Are we moving towards a significantly increase in application to the commercial markets in the futures? The question performance or price is still an open question and an open question mark. It's still the trade-off or the optimal working point is still open. Is these trends that we are all pointing on that will be here with us also after the pandemic? The critical role of the Earth observation capabilities will be as much in the globally also after the pandemic. And what is valuable data and what is actionable data, and how we are going in a evolution from data to information, and maybe the what that you said, Guy, more and more data, more information, more actionable data. What will we want to know in the future? Maybe this is the end questions of this panel. So thank you very much for the discussion, for sharing us all your perspectives, and thank you for the organizers. And thank you all, and see you in the next conference. Maybe it will be a physical conference.
Thank you, Ms. Kreis, for leading that session. It certainly was an interesting discussion on whether satellite-based remote sensing is a revolutionary process or evolutionary. I hope you enjoyed these panels. To continue with our agenda, please go to the main stage for the next session.